So we're now going to move on to the final future briefing of the day. If I can get my buttons to do what they need to do. It's getting late here. I'm pressing the wrong things as we go. We have a final future briefing. Now, this future briefing actually is going to be from Ian from the I've typed it wrong on there. Sorry, Ian. I'll correct that afterwards. From Ian from the BBC. Now, I saw Ian's presentation a few weeks ago on a series of webinars about 5G in the creative industries. And as many of you will know, I'm sometimes a bit down on 5G because it's just another fast layer 2 technology for me. So I was really quite buoyed up when I saw Ian's presentation, because he was presenting some elements in the content delivery ecosystem, which I felt were very pertinent to the CDS audience. And I thought we should bring him in to talk a little bit about what he's been doing. Now, he's dealing with some edge compute technologies, and he's also dealing with contribution technologies, which I do feel are all part of the content delivery ecosystem. So this should be a little bit of fun as much as anything else, but some real world practical uses of some of the technologies that we've been looking at over the day. Ian, are you out there?
Yeah, I am. Can you hear me? Can you see me?
I can, and it should jump to you in a second. I'm just going to spotlight you and hand over.
There I am. There I am. Look,
there we go.
Brilliant. Excellent. Hello, everyone. Thanks for the intro, Dom, and thanks for the invite. I'm going to share my screen and just double check this works, if that's okay. Is that going to? Should be fine. And let's do a little bit of this, and hopefully you're seeing my presentation there.
Absolutely fine.
Excellent. That's I'll just double check you're seeing the full screen version, not the preview version. Good.
I've got I don't know. I've got speaker slides. I've got your speaker
okay. Hang on. I'll swap that then.
Yeah.
Is that the right way around? Yeah, it's different every time you do it. Right. We can start. Good. Okay. So yeah, thanks, Dom. I'm Ian Wagdin. I work for BBC R&D, and as Dom said, I've been looking really at how we might use 5G, but also some of the related kind of connectivity technologies, really for live production. This will give you. I'm also part of a group called 5G Mag and a couple of other European perspectives. So this is probably very, very much a European focus on where we are now. But I do recognise that actually different markets have progressed along the journeys in slightly different ways, and we'll touch on that in the beginning. But let's just kind of start with some core stuff. So really at the BBC, we create some content, we make stuff, then we shift it around. And then we send it out to our audiences, and all of these things are, we've been doing for a number of years, and we're pretty good at it, and we kind of know what we're doing. But they all rely on sort of various different bits of connectivity and compute power and sort of end user devices and all of that kind of stuff. And we've been doing it. Well, next year is 100 years we've been doing this stuff, and obviously it's changed a lot over the time. So at the beginning it was kind of very analog, and it was analog for probably up to the 90s, and then we started to get digital technologies which enabled us to kind of squeeze more into available bandwidth, but it's all sort of very unidirectional, and it's been brilliant technologies, and we use that all the time, and we also use a lot of radio layer stuff as well, and a whole bunch of other bits and pieces. But now we're in this midst of this migration to IP and Internet Protocol. And basically what that means is we can use a whole bunch more of kind of cloud technologies, and we're starting to design systems now that are more software based rather than kind of specific hardware based technologies. And obviously alongside that, the telecoms industry and the mobile industry have kind of been moving along that route as well. So as we move to IP, we're starting to think about what our radio technologies look like that support these IP workflows. And the other thing that's important to us, and this is a slide from Qualcomm, so I'll give them the credit on this one. But this slide really looks at different areas of spectrum and how they're deployed in different territories. you can see that in the US, we've got a whole bunch of technologies that are deploying very heavily up in the millimeter wave space. More in Europe, we're doing a whole bunch of mid-band stuff. And down here, again in Europe and particularly in the US and Canada, we've got some sub 700 megahertz. And for those of you who don't know, in Europe, a lot of that spectrum is used for our broadcast TV, where we our over-the-air services and our terrestrial television. But what we're recognizing is a lot of these technologies that we currently use our radio technologies in are starting to be eaten up by some of the services that have been provided by telcos and other people. And spectrum's a finite resource. So we sort of started to look at various technologies to see how we can mitigate against these two challenges that we've got coming up. And how do we do that? Well, we kind of do 3 or 4 things really. We look at standards and regulation. We test and we try stuff out, and then particularly we look to partner with other organisations and similar people to try and be bigger than the sum of our parts. And then we plan it out over kind of what can we do in the short term, what can we do in the midterm, and then what can we do in the longer term. And these really kind of break down into things like very quick and dirty tests and trials. So we're doing some stuff at IBC in about a month's time where we'll be showing off some of this technology. Then we've got some slightly longer bits of work where we're engaging with both industry, with academia, with other creative industries, and then in the long term, we've got long-term engagements with our own regulations, Ofcom, and also with standards bodies. So how do we do this kind of industry influence and governance is this bit. So there's a number of places where this is really critical to us. So in the 5G space, we're working in the standards bodies with 3GPP. In Europe, we're working with ETSI, and then at a global level with ITU, both T and R. And then specifically for 5G, we're also members of a group called 5G MAG, who are a media representation partner. And what they're doing is they're looking at both the distribution and the contribution models and how we might use those technologies. And then underneath that, we need to engage with companies or with regulators. So Ofcom, in our case, for spectrum, we need to engage with people in, looking at codecs, people looking at transport layers, for instance, W3C, SIMPTE, who are broadcast stuff. And all of this is about getting the landscape right. So we spend a lot of effort trying to just get that base layer right. And this is just kind of cuts right across everything we do. So I'm going to talk really briefly about some stuff we've done with distribution. I'm not going to major on this. I'm just going to kind of talk about some examples where we've done some tests and trials in the UK. Some stuff around using what we call the smart tourism, which is really kind of augmented reality and the use of 5G to support that. And then similarly, some broadcast trials we've done up in a very remote part of the UK called the Orkney Isles, which is way up off the north coast of Scotland, for those of you who know, who don't know where the Orkneys are. So firstly, this type of technology is really exciting for us from our audience point of view. This is the Roman baths in Bath. So about 1,000 years ago, the Romans were in the UK, and they built some nice baths that still exist, and you can go and see them. But actually, we're also using 5G technology to give you a kind of augmented reality tour of this stuff. And this is actually relying on things like edge compute in order to deliver low latency experiences. So as you move your device around, you can see how the baths have changed over time. And then up in the Orkney Islands, we've been looking at actually how can we do broadcast radio over 4G and 5G. And this means that we've got to kind of slightly redesign some of our content. And that, again, is using little bits of CDN technology and little bits of caching technology on the edge to kind of deliver these services, but to places where you wouldn't normally deploy connectivity, because there just isn't the density of population there to support it. And that involves us actually building stuff as well. So we work really closely with a number of companies to kind of build our own 5G network, and with the UK government actually to build a 5G network that could support these radio services. So we've done that, and that's a lot of the stuff we've done with distribution. And then recently, and this is really my area of expertise, we've started to think about actually, okay, well, what are we doing with production? and as you can see from this picture, we've been using kind of radio links and satellite links and a whole bunch of stuff for many years. So we're unusual really as a vertical, because we've already got a whole bunch of knowledge in how to kind of use radio and how to interoperate with it, and also around regulation. But when we start to look at where the particular challenges are in production, the biggest one we've got is throughput. So you know, even if we're working at HD, let alone 4K or above, we're pushing huge amounts of data up in across networks, and a lot of the challenges we've got are those networks are designed to do downlink. They're not designed to take this amount of traffic. Latency is really important to us, but not the kind of latencies that you guys are talking about. Actually, most of our stuff we can probably work within a kind of 100 milliseconds, and we can get kind of quite responsive or responsive enough feel for a lot of our kit on within that kind of 100 milliseconds boundary. And I'll come back to that because it's really important. And then timing. If you've got two cameras that are pointing at the same thing, you need to make sure they capture that detail at the same thing. So we need to think about actually what are our timing services and how do we synchronize bits and together. And then really important to us that reliability. So, you know, if you pay a lot of money for broadcast rights for an event, or you're covering a national event such as a royal wedding or similar, you need to make sure that you're going to stay on air. And that's, you know, that's our core business, and we get penalized very heavily if so we can't really compromise on that. But actually, when we start looking at these networks, we're really quite challenging, because our patterns of work tend to be very ad hoc and nomadic. So that, you know, we'll plan something maybe a month, 2 months in advance, and we'll spin it up, and then we'll use it for a couple of weeks, and then we'll turn it off. And that's kind of completely different to how big mobile network operators work. They tend to kind of plan things for years, and then you build something and it lasts for 5 years. So, you know, there's a little bit of conflict there. And then similarly, kind of rural remote support, we need to kind of, we don't necessarily always want to be in the high density areas. And then really importantly, the types of network are important to us. I'm just going to kind of put this slide up there as well, because it kind of indicates a lot of the traffic we're carrying. So, you know, you often think about the program video, but there's a whole bunch of other services that a camera will typically require, and these are per camera unit. So if you've got 5 cameras, and you need to mount this up. So, you know, and traditionally in the radio layer, we've maybe put different radio services to support these. So things like audio would be on VHF, and lighting control, you might use a Wi-Fi communication, and timing and sync is a kind of more pulse, and then you've got kind of COFDM level stuff for program video. So there's a whole bunch of different technologies that we're using, and we're trying to, one of the advantages to an IP based solution like 5G is that we can multiplex a lot of these signals together and hopefully be more efficient in the way we use radio. But I think the other thing, when we talk about 5G, is a lot of people think about the big public networks and the kind of things that you get from in our case, you know, Vodafone or you know, an AT&T or a Verizon. But actually, we're starting to think very closely about actually what does it look like if we build and own our own networks. And there are different kind of terminologies that exist within the 5G space. So the PLMN is a public network. That's the sort of thing you get from your network provider that drives your mobile phone. But underneath that, and that's really what we've had up till now. We've kind of bonded cellular and LTE. But actually 5G is starting to enable all of these different technologies. And I know there's a whole bunch of 3-letter abbreviations on here, but things like traffic prioritization, slicing, and we're talking about a lot. PNI NPN is basically a non-public network or a private network that's built on the infrastructure of a public network. And those are going to require some sort of contractual agreement. And then finally, right at the end there, we've got standalone non-public networks, which are the kind of networks where we can build and deploy them ourselves. And really, there's differences around all of those. And to the left, we tend to have less control over the kind of traffic we can put over the network. We've got more control on the right. They need more planning. The further you go to the right, where they can be a little bit more ad hoc on the left. And you've got global coverage really on a public network where private networks likely to be hyper local. So all of these things have a place and different ways of doing that. So to understand them, really, we kind of need to move into these kind of tests and trials and working stuff out. So we're actively doing that. We're looking at all sorts of things around non-public networks and how we might deploy those. And the reason we're starting on non-public networks is because for us, the public networks are what the telcos are there to deliver. But the non-public networks, well, actually, we think we can do some interesting stuff there. And then the middle ground will naturally fill itself in as the technologies become available. But all of these things, the codecs and transport, are important to us. Audio. Now, audio is interesting because, as I mentioned earlier, we use radio mics in certain spectrum, but those need to be extremely low latency. As you can imagine, you can't have any latency, otherwise you hear yourself starting to come back, or it's out of sync with pictures, depending on your application. So audio is a particularly challenging user case. And then how do we do timing? So we're looking at, a lot of these networks support PTP, but is that too granular for camera timing? But then do we need that for kind of RTP header streams in when we're looking at streams? And then there's other things like how do we deploy public networks? And then finally, this kind of question of edge compute. And edge is really interesting because everyone sells it to us as a low latency scenario. And for us, that's not really a huge challenge for us. As if I'm using a data center and I've got tools that are based in a data center, I can typically hit that data center in 20 milliseconds or whatever, and that's really a frame of video for us. And that's within our working tolerances. And somebody comes along and says, oh yeah, but if you deploy edge compute, well, you can maybe get that down to 10 milliseconds. Well, actually, the cost of doing that probably doesn't stack up against the cost of deploying that. Now, this is very specific in the production place, typically because we have, maybe 4 or 5 cameras that we need to do this with. It's not, I should be really clear, in the distribution case, I do think that there's more of a case for it when you want to render maybe video to multiple users. But in the production space, the latency argument is not the big selling point for us. Really, what the big selling point is, as I said earlier, we needed to move really high bandwidth content around, and that high bandwidth comes with a cost. So the more we can do at the edge and then move around compressed video, or just move around the video that we want to move around, rather than or pre-selecting content, we would do that at the edge. So it's about reducing bandwidth for us, not necessarily reducing latency. I think that's a really important point. And then finally, how are we doing it? Well, actually, we're looking at this is an example of a really small scale non-public network that we've been working with the University of Strathclyde with. So we can effectively, you've got a radio head and you've got a core network, which is what's kind of shown here in this skull candy box, and we've got a kind of a Qualcomm modem that's running sort of on a USB device here. So these things aren't the big networks that you think about when you think about Verizon or AT&T or Vodafone. These are kind of really small scale things that we can deploy. And because all of our power is in the wrong direction as well as our traffic, that means that we can get licenses to sort of deploy very low output networks to support production. So it's kind of a very interesting space because we're not using the way the networks were necessarily designed to do. Finally, I'm just going to talk a little bit about some projects and partnerships that we're involved in, and I think these are key because these are key milestones about where we're doing this work. So some of you may know the EBU, the European Broadcasting Union, basically public service broadcasters from across Europe and actually affiliates are slightly wider in Japan and Australia and a few others, similar to Neighbor in the US. And so we're working with those guys to really kind of as a broadcaster, is almost facing off against the telcos because we're not big enough as sort of individuals, but when we join together with multiple broadcasters with the same message, that's really important to us. I mentioned 5G MAG earlier. There's a whole bunch of stuff we're doing in the UK, which is run by our Department of Digital Culture, Media and Sport. DTG is a European-based digital technology group. And then we're also working, I'm going to touch on these last two very quickly, the Horizon 2020, which is a kind of funded research program, and then the IBC accelerators. which again I'm going to touch on in a bit. So the first thing really we're trying to do here is join up a whole bunch of stuff. So it's no good having all your cloud stuff and your edge stuff if you can't get into it. So connectivity is really key for us here, and how we pull this stuff together. And we're looking at things like LEO and low Earth orbit satellites as kind of new connectivity technologies for contribution. And we're looking at 5G both for production links as well as contribution links. And then we need to integrate those into different services running on different cloud solutions. So we're really starting to think about actually not just one part of, not looking at data centers or not looking at cloud and not looking at connectivity as separate things. They all need to join up. And I think what's really challenging here is usually it's around the last mile connectivity, and that's where perhaps 5G can help us a little bit to kind of move our content around. How are we doing it? I think this is a really interesting project. This is one, it's a 2-year European funded project. We're looking at 3 areas of production here. One around kind of live audio production and the kind of radio mic case that I told you earlier. The second one really looking around cameras and how we use non-public networks to do that, which is kind of similar to what we talked about earlier. And then finally, starting to kind of look at future production models, so kind of what we call live immersive production. And again, we're using edge compute here, and the idea with this is that we've got an array of cameras that are kind of all capturing media, almost in a kind of matrix time slice way, but with video. And what that means is that we can effectively create content from any angle, and then we can use that to output that content, or in future we'll be allowed to, we'll get our audiences to be able to pick the angle that they want to watch stuff from. So that's kind of really exciting, and that does require sort of edge compute to just manage a lot of those signals. I'm conscious of time, so I'm not going to go through this too much in detail, but again, this is the kind of idea where you might have 3 or 4 cameras all connected on over 5G that we're then bringing into our 5G networks, but we then need to also bring those into our production networks, and those might be localized production networks that are running in broadcast centers using specific broadcast protocols, or they might be cloud-based networks which may have different sort of connectivity or even different constraints to those that we have on our private networks, security or performance issues and all of that kind of stuff. And then the final thing I'm going to talk to you about is actually some really short-term stuff. And if you're at IBC in December, or you join us online, we'll be talking around some of the detail a little bit more about this. So we've got a number of areas where we're really talking about this. We've got a kind of 5G innovation in live workflow project, which is really kind of bringing together a lot of this stuff. We've got some specific stuff around remote production in sport, and then we've also got kind of more of a distributed thing, which is a kind of location-based extended reality test and trial that we're doing, and all of these things are really exciting. So if you're at IBC or you get a chance to kind of tune in, you'll be able to see a lot more on this subject as well. That's it from me. I think we're slightly over time, so apologies for that if I've kept you a little bit longer, but hopefully you found that interesting.
Absolutely spot on, Ian. Thank you so much. I'm really glad we got you to come along, because you really touched so many points in the whole content delivery ecosystem. I felt it was a really good closing future briefing for the day. It should get some of the participants and attendees thinking about all sorts of different aspects of the content delivery system. So just a sort of a very broad overarching question. One of the things I mentioned at the beginning, I'm sometimes a little down on 5G because I view it as just another fast layer 2 network. Yeah. Obviously its radio nature means that it's now a very fast network that's becoming available in many locations, rather than maybe where the Ethernet termination was in the wall and so on. But what's the really, for you, what are the really big standout things that 5G is bringing you as an organization to these workflows?
Yeah, okay, so I think the first mistake we've got is that we've got this kind of 5G thing going on, which is really just a marketing term. And we need to think about this as just kind of a continuum of new technology rollouts. And actually, there's multiple different technologies that are involved in 5G. the marketeers have got hold of it, and effectively they've branded it and they're selling it to us. But I think really what's important is actually to kind of look at how these networks will evolve over time. So, you know, if you go and buy a 5G phone now, it's going to be completely different to the 5G phone or the services you're going to have that run on 5G in 5-10 years time. And at some point marketers will come in and put a 6 on, or they call it 5G advanced. We know they're doing that, and that's the plan. But yeah, your question about what's the most important thing, I think for us it's part of this transition to IP, and at the heart of it, IP and this kind of bi-directional sort of traffic, and moving to the way that the internet handles content differently to the way that we've traditionally handled content in our digital workflows, which are kind of unidirectional, means that we can start to create content and store content in a different way, which means that we can then personalize that content a lot more easily for our audiences, if that makes sense. So that means that we can start to move away from where we were kind of either we were rendering at at creation, which was creating a single file that we then broadcast. We're currently in a kind of render at distribution where we can deliver sections of files, and then you can make choices about how you bring those down depending on which territory you're in, and usually it's the kind of broadcasters or the content distributors who make those decisions, whether that's the likes of us or Netflix or an Amazon, who want to regionalize and localize content. But actually where we really want to get to with this stuff is render at consumption. So you as an end user can personalize the content you want, and you might want to do that for accessibility services, or you might want to do it because you're watching it on a different device, or you might want to just kind of have a personalized catch up or a thing like that. And I guess that just to kind of briefly answer your question, it's not that 5G is exciting, it's that actually the ecosystem that is supported by 5G as connectivity that I think is the exciting bit.
An interesting use of the word personalization that came up in the video workflow panel a lot, and I think that's going to be a word which I anticipate by our next content delivery summit will have become even more dominant in the CDN landscape. So
yeah, I mean it's massive for us actually. The what we call object-based media, or there's several things you can do with that tech. You can either deliver as I say, accessibility stuff, but you can either look at it as branching narrative and different ways of telling stories, or you can look at it as maybe you can change the temporal stuff. So you could do maybe automated highlights where you kind of say, actually, I've got 20 minutes, show me the highlights of, whatever the current thing that you were watching last night on. I won't do a regional reference, but if it was a sports match and you just got 20 minutes on your commute and you just want to catch up on that, then here's the 20-minute highlight. But if actually my train gets delayed, actually here's the half-hour version, I've got an extra 10 minutes and all that kind of stuff. So we can start to be a lot more responsive in that personalization of content.
It's very interesting. Just one last comment there. A very close friend of mine is one of your the BBC Southeast camera guy down in my area, and it's been interesting watching how his workflow has evolved over the last sort of 8 years as mobile signals mobile has become a ever more dominant means for contributing content. He is so much faster with his workflow because he doesn't have to point a dish anymore.
Yeah, I mean, all of that
has saved him hours.
Yeah, no, all of that stuff. And we'll be streaming. We're doing experiments now. We're actually just kind of constantly streaming the cameras back now, and that means that we can turn. News is one workflow that is just constantly hungry for content. And I think, as I said earlier, some of that stuff's being solved by the market, but then we're looking at these kind of the other end of the market. So when you think about the bikes on the Tour de France or on a marathon or stuff like that, where you really want to kind of cover things on a sports event that have to then match in with wired cameras, that's a kind of different story as well. And that's where the latency and the bandwidth come in, because you need to really think about the quality of those services.
Ian, can't thank you enough for me allowing me to jump on you and drag you into our event. It's been absolutely fascinating, and I'm sure everyone would be joining with me in a round of applause, and also looking forward to hopefully hearing from you in broader streaming media events as well, because I think there's an awful lot you can teach us about the practical realities of the next generation of content delivery. So thank you, Ian, much appreciated.